All right, today we are going to solve 3 by 3 systems, which means we are now going to have 3 equations with 3 different variables, so x, y, and z. All right, to do this, we are going to solve these systems using substitution and elimination together. Okay, so this first example, you'll see they're stacked on top of each other by variable. And I'm going to solve this one by substitution, because right here I already have z equals 3. So what I'm going to do is I'm going to plug that into the equation above it so I can get y by itself. So I'm going to say 2y minus z, which is 3, equals 7. So add that 3 over to get 10. Divide, we're going to get y is equal to 5. All right, now I have 2 different variables, but I have to get the z one also. So I'm going to take x, z into here and y into here, so that way we can now get x by itself. So 3x is going to equal, not equal. When I replace in my variables, we will get 3x plus 5 plus 2 times z equals 8. Okay, so this gives me 3x plus 5 plus 6 equals 8. Add those together, subtract it over, and divide. We get x equals -1. Right? When we write our answers as a coordinate point, we always did x, y. Well, now that there's a third variable, it's going to go x, y, z. So our answer needs to be written -1, 5, and then 3. All right, let's do another one. Again, I'm going to use substitution. I'm going to be able to solve for z pretty easily right here. So to get z by itself, I'm going to divide both sides by 3. So I'm going to get z is equal to -2. Take that value, plug it into the equation above, so now I can get my y by itself. So it's going to be 4y minus 3 times z equals 10. So 4y plus 6 equals 10. 4y is going to equal, subtract that over to be 4. Divide, y equals 1. Now we're going to take both of the variables I have now, y and z, and plug it into this first one. So 5x minus 3 times 1, which was my y, plus 4z, which is now -2, equals 4. So 5x minus 3 minus 8 equals 4. 5x minus 11 equals 4. Add that over, and then divide. We're going to get x is equal to 3. So again, when I write these down as a coordinate point, we're going to do x, then y, and then z. So our answer is going to be 3, 1, -2. Okay? So that is substitution. Now we're going to bring in elimination, okay? We'll do elimination first, and then we're going to substitute our values back in to get the rest. So we do elimination to get the value of one variable, and then we're able to plug them back in. So notice for this one, our second equation was missing a y. Third equation was missing an x. So that's why we have those spaces there, because we want to keep our equations stacked on top of each other. All right, so to eliminate, okay, we're going to use our first equation and one of the other two. So I'm going to number these to make life a little bit easier. So equation 1, equation 2, and equation 3. We're going to pick 2 of those to put together to eliminate a variable. I want to either eliminate the y or eliminate the x, because that's what's already missing in the other 2 equations. So I'm going to pick equations 1 and 2. And I'm going to eliminate the x, okay? So to do that, I am going to multiply this first equation by -2. So we have -2x minus 2y minus 2z equals -10. Second equation, I'm not going to change. I have 2x, I have plus z, and I have 8. My x's cancel. Negative 2y drops down. Negative 2z plus 1z is negative 1z. Negative 10 plus 8 is going to give me negative 2. Okay? And we're going to call this equation 4. Right? Notice equation 4 and equation 3 both only have a y and a z variable. So we're going to put those two together first to eliminate the y or the z. So we're kind of doing a couple of rounds of elimination to get there. All right? So we're going to put 3 and 4 together. And I am, let's see here, 3 and 4. Looking at these, I'm going to multiply my equation 4 by 2, because that's going to help me eliminate the y's. So I'm going to leave my equation 3 just like it is. Well, not my y's, I'll eliminate the z's. If I multiply equation 4 by 2, we're going to get negative 4y minus 2z equals negative 4. My z's are now eliminated. I'm left with negative 1y equals 1, so we get y equals 1. So we have finally gotten a variable by myself. Once we get down here, we don't have to do any more elimination. Instead, we have to plug it back in. Okay? When we plug it in, we're going to work backwards. So I use equations 3 and 4 to get y equals 1. So I'm going to take y equals 1 and plug it back in to one of those equations, 3 or 4. Okay? I'm going to choose to plug it into equation 3. So I'm going to replace this y with this y. So 3 times 1 plus 2z equals 5. So 3 plus 2z equals 5. Subtract the 3 over to get 2. I get z is equal to 2. Now I have 2 of my variables. So I have to plug them both back in to one of my original equations to finally get x. So I'm going to plug them both into equation 1. There's a couple ways to do this. You can also just plug z into equation 2. That could also give you an x. It does not matter which way you do it. Okay? To keep it consistent, I'm going to plug it into the equation that has both of these pieces. So here's the y, here's my z. I'm going to plug them in there. So I'm going to have x plus my y, which is 1, plus my z, which is 2. That's equal to 5. So x plus 3 equals 5. So x is going to equal 2. Which I think I messed up. Yep, I messed up. What happened? Z should be 4. Oh, look at that. Y was negative 1. See? A small little sign is going to change everything. 1 divided by negative 1 is negative 1. So that means when I plugged in my y's, that should be negative. So that's negative 3. So I'm actually going to add it over. Okay. To get 8. So my z is actually 8 divided by 2, which is 4. So when I plugged it back in, it should be x plus 1 plus 4. Oh, look at that. It's not plus 1. It's minus 1. Equals 5. Negative 1 plus 4 is 3. There it is. And 5 minus 3 is 2. So our answer here is 2, negative 1, 4. Watch out for your signs. I just showed you. If you change a sign, it's going to change the whole equation. So don't rush through it like I am. Okay, number 4. Here, all of my variables are there. Nothing is missing. Okay? So again, I'm going to number these equations. So we have equation 1, equation 2, and equation 3. Okay? I need to set up 2 different pairs of elimination problems and eliminate the same variable each time. So that way when I get equation 4 and equation 5, they both have the same 2 variables in them. Okay? So I'm going to choose to eliminate the x's. here. You could do X, Y, or Z. It is totally your choice. I'm going to pick X just because I like those numbers that I see. I'm going to put, let's do 1 and 2 together first. To put those together, I am going to multiply the second equation right here by -2. So my first equation is not going to change. My second equation multiplying by -2. Remember, the whole point of this is to eliminate the x value. So x's cancel. We now have 5y plus z equals -7. All right, so we're going to call this equation 4. So when I do elimination again between two other equations this time, I need my equation 5 to also just have a y and a z. Okay, we had to do this last time because I already was given an equation that was missing a variable. Okay, here I don't have anything missing a variable, so I'm going to have to make it happen. All right, so I need to pick 2 more equations and eliminate my x. So I'm going to pick, let's do, how about 1 and 3? Put those together. Goal is to eliminate x, so I'm going to multiply my first equation up here by +2. I'm going to have 4x plus 2y plus 6z equals 18. We're not going to change the third one. All right, x is canceled out. That's what I wanted. Now I have 5y plus 8z equals 14. And we're going to call this equation 5. Notice equation 4 and equation 5 both have a y and a z. That's what has to happen, because then you're going to use equation 4 and equation 5 to finally get a variable by itself. Okay, so looking at these two, I think I am going to eliminate the y's. Okay, and I'm going to do that by multiplying this second equation by -1 to get -5y minus 8z equals -14. Y's cancel. 1 minus 8 gives me -7 equals -21. Divide, we get z equals +3. Okay, now we finally have one of our values, so now we can start plugging it in. Okay, again, we have to work backwards. So when we got z equals 3 by using equations 4 and 5. So I need to take z and plug it back in to equation 4 or 5. All right, I'm going to choose equation 4. So I'm going to say 5y plus 3 equals -7. So 5y equals -10. Divide, y equals -2. All right, and then we're going to work backwards again. This time I want to plug it in to one of my original equations. So we can do it into 1, 2, or 3. I'm going to plug it into equation 2. So remember, equation 2 was x minus 2y plus z equals 8. So we don't know x. I know my y, though, is -2, and I know z is 3. This becomes x minus 4 plus 3 equals 8. What did I do? Oh, plus 4. There it is. So it becomes x plus 7 equals 8. Subtract that over. We get x equals 1. So our answer will be my x, my y, and then my z. So -1, +1, -2, and then +3. Okay. One more. Number 5. So again, we have all my variables. So we're going to have to create an equation 4 and 5. So to do that, we have to bring a combination of these first three equations and eliminate the variable twice. So, looking at these, I think I'm going to eliminate x. I'm going to do that by using equations. I'm going to use 1 and 2. And then I think I'm going to do it again with 1 and 3 afterwards. Okay, so my goal, I'm going to eliminate x first. Okay, you don't have to. If you would rather eliminate your y's or your z's, you are more than welcome to do that. Okay, you will still get the same answer that I am getting, as long as you do it right. Okay, so I'm going to eliminate my x. So with 1 and 2 right here, I'm going to multiply my first equation by -2. So we're going to get -2x plus 4y minus 2z equals 18. Equation 2 is not going to change. Minus 3z equals 5. Get rid of that x. We now have 6y minus 5z equals 23. We're going to do it again with 1 and 3. Remember, we have to eliminate x again because we need to have an equation, two more equations, two new ones, equation 4 and equation 5, all right, that are going to only have a y and a z now. I'm eliminating x twice. So this time, I'm going to use 1 and 3. And what's nice, I don't have to change anything because they already have x's that are opposites. So we're going to have x minus 2y plus z equals -9. And then equation 3 is -x plus 3y plus 4z equals 7. X is eliminated again. They have to. -2 plus 3 is going to give me 1y. 1z plus 4z gives me 5z. And then -9 plus 7 is going to give me -2. So notice my equations 4 and 5 both have a y and a z variable. So we're going to put those two together next. All right, and if you notice their z's, you already have one positive and one negative, so I don't have to manipulate anything. I can just write them as is. So equation 4 was 6y minus 5z equals 23. Equation 5 was 1y plus 5z equals -2. The z's got to cancel. We have 7y equals 21. Divide, and we get y is equal to 3. All right, so that means we are done with elimination. Now we have to start plugging things in. So again, y can only get plugged in to equations 4 or 5 because that's what was used to get it. I'm going to plug it into equation 5. Okay, so my y is 3 plus 5z equals -2. Subtract the 3 over to get -5, and then divide by 5 to get -1. There's my other piece. Finally, we're going to take y and z and plug it into any of my original 3. I think I'm going to plug it into our first equation. So remember, our first equation was x minus 2y plus z equals -9. Well, I know y is now 3, and I know z is -1. So x minus 6 minus 1 equals -9. X minus 7 equals -9. Add that 7 over. We're going to get x is equal to -2. So our answer here is going to be -2, 3, and -1. Because again, we put it in x, y, z. All right. Okay, so you are going to do number 6 for homework. Okay. This is homework. When you are doing this one, I will give you a heads up that you will have 2 answers that are fractions. Okay. So this one right here is your homework. And 2 of your answers will be fractions. All right, good luck.